Assalamu alaikum wa rahmatullah. Today we have a new lesson of geometry. This lesson is distance between 2 points, Unit 5, Lesson 1, Part Number 1. Mrs. Manal Salahuddin with you. Let's start our lesson today. We studied before how you can find the length of any line segment. As we can see, here we have line segment joined between the tree and the car, and I want to find the length of this line segment. First, you can use the ruler or measuring tape. Second, we can use Pythagoras theorem. Here, he asked me to find the distance between the car and the tree by using Pythagoras theorem. Now, I will count the horizontal units and vertical units. The horizontal units equals 7 and vertical units equals 5. Now, I have right angle triangle and the line segment represents the hypotenuse of this right angle triangle. Now I can use Pythagoras theorem. Then d square equals a square plus b square. That means a equals square root of a square plus b square. By substitution method, d equals square root of 74. Now I can write the value of d in decimal form. D approximately equals 8.602 units. Try this problem yourself. Find the length of line segments which join between the house and the bus by using Pythagoras theorem. Stop the video, solve the problem, then check your answer. Now, the answer will be d equals a square root of a square plus b square. Then d approximately equals 12.73. Now, let's watch the following video together. In the video, we'll learn a new method to find the distance between any 2 points. Let's watch.
Let's start off our lesson on the distance formula by asking ourselves, what is distance? We can think of distance as a length between a starting point and an ending point, just like a starting line and finish line in a 100-meter dash. When we use the GPS, we're looking at distances between a starting point and an ending point.
Starting route to San Francisco.
Just like the drive from San Diego to San Francisco would be a distance of 502 miles. So for this lesson, we're concerned with finding the distance between two endpoints connected by a line segment, in this case line segment CK. If we measured this line with a ruler, we could say that CK has a length of 13 centimeters.
Ooh.
And we are going to extend this idea of finding distance between points on the coordinate plane. Please note that distance is a measure of length, the words are interchangeable, and distance is measured in units. Finally, when finding distances on the coordinate plane, our tool is not going to be a ruler, but the distance formula. So let's go ahead and learn how to use the distance formula. Our first example calls for finding the length of line segment AB. Now, when we see the word length, we should be tipped off to use the distance formula. First, we're going to need the coordinates of the endpoints A and B, with A at 3,7 and B at 7,4. Now again, A and B are both points with x and y coordinates. Since A is the first point, we'll give it the 1's x1, y1, and since B is our second point, we'll give it the 2's x2, y2. And now we're ready to use our formula. Let's start off by looking at x1 and x2. x2 is 7, x1 is 3, so we have 7 minus 3 in parentheses on the left side of the equation. Now we can slide that over and look at y2 and y1. y2 is 4, y1 is 7, so we have 4 minus 7 in the parentheses on the right side of the distance formula equation. And now that we're done substituting, we can begin to evaluate. 7 minus 3 we know is equal to 4. On the right side, 4 minus 7 is equal to negative 3. Now we can evaluate the exponents. 4 squared is equal to positive 16. And we're adding that to negative 3 squared, which is equal to positive 9. Remember, a negative number squared is a positive value. And we know that 16 plus 9 is equal to 25. And finally, we can evaluate the square root. The square root of 25 is equal to 5. So what we just found is that line segment AB is 5 units long. Now, real quick, if we look at AB as the hypotenuse of a right triangle, we notice that the legs of the right triangle are 3 and 4. This is your classic 3, 4, 5 right triangle. And this value of 5 can also be found using the Pythagorean theorem. So we should see that the distance formula actually comes from the Pythagorean theorem, a squared plus b squared equals c squared. For our next example, we're going to be observing a quadrilateral on the coordinate plane with endpoints w, y, c, and m. We want to find the length of line segment WC, so we know we're going to have to use the distance formula again. Notice that W and C are diagonal from each other, so this is a diagonal of this four-sided figure. So we have to construct that line to help us visualize what line segment WC looks like on the coordinate plane. Now we can write down the coordinates of W at negative 6, 4, that's your x1, y1, and C at 4, negative 2, that's your x2, y2. In the distance formula, we can now substitute x2 minus x1 is going to be 4 minus negative 6. Then on the right side of the distance formula, y2 minus y1 will be negative 2 minus 4. So now we can continue to evaluate 4 minus negative 6. The double negative becomes a positive, so 4 plus 6 equals 10. And on the right side of parentheses, negative 2 minus 4 is equal to negative 6. Now the exponents, 10 squared is equal to 100, plus negative 6 squared is equal to positive 36. And 100 plus 36 is equal to 136. And now we just need the square root of 136, which is going to equal an irrational number. And since the question asks us to round to the nearest 10th decimal place, we'll round our answer to 11.7, the length of line segment WC.
Oh yeah!
Please follow us on Instagram at MashupMath for free daily math tips and infographics.
In the video, we watched how to use the distance formula. Formula means rule. Now, we have a new rule to find the distance between any 2 points by using the 2 coordinates of each of them. If I have 2 points A and B, A is x1 and y1, B is x2, y2, then I can use the formula. The formula is D equals square root of x2 minus x1 squared plus y2 minus 1y1 squared. D means the distance between the 2 points. For example, find the distance between the 2 points 2 and 3 and negative 4 and 6. Here I have the 2 coordinates of 2 points. First point, 2 and 3. 2 x1, 3 y1. The second point, negative 4 and 6. Negative 4 x2, 6 y2. Now I can use the rule. Firstly, write the rule. Then, by substitution method, D equals square root of negative 4 minus 2 square plus 6 minus 3 square equals square root of 45. Now, I can convert this irrational number into decimal form. Then, approximate the answer to the nearest 2 decimal places. The answer will be 6.71. Now, try these problems yourself. Find the distance between the 2 points of each of the following. Here I have 4 problems. Now, stop the video, solve yourself, then check your answer. Now, the answer. The first one, the answer equals 20. The second is 5. The third one is 13. And the last one is 17. Now, don't forget solve the homework. Thank you for watching. See you in distance between the 2 points part number 2. Thank you and goodbye.